Hello viewers, in today's video we are going to see how the searching working on binary search tree. First of all, we understand what is binary search tree. Binary search tree is a type of tree in which the left subtree contains the element less than the root node and the right subtree which contains the element which is greater than 6. Then now we look at the search operation performed in the BST, how searching will be done in the BST. For example, we have to found whether the key 7 is available in our tree or not. So, first of all, we were going to check whether our current node is equal to, first of all, we are pointing towards current node and compare the key with the current node, that is whether it is equal to our current node or whether it is smaller than current node or it is greater than current node. Clearly here we are seeing that our current node is 6, which is smaller than our key, which means key will be appear in next subarray, greater subarray. So again we move to our next current node, we point 8 as our current node. Again comparing with 8, we see that 8 is greater than 7, which means 7 should be smaller than 8, and smaller element are always in the left subtree. So we move to left subtree. Now our current node pointing toward the left subtree. So here we can clearly see that 7 is equal to the key which we have to found, and this operation will return true. Now we are going to take a look how we can implement this in our C++ language. Again, I am using the GFG platform. First of all, we will implement if our current node data is equal to key, then we have to return true. And second condition will be arise whether our key is smaller than the root data, current root data. So let's check this condition also. In this case, we will recursively call the search. We will recursively call the search function again and again for root left. Since since our key is smaller than root, which means it should the key should be found in our left subtree. So we are recursively call this. Here we put a condition whether if our root will be null, then we simply return false. This is the base condition. This will our base condition. Now we left with the last condition, if the key is greater than our root data. So we simply put in our else part. So we will call the no root right side, because if our key is greater than root node, then it will be implement search on right side. Now our condition satisfies, so quickly check this out to compile and run this code. This will say compilation error. Yes, here. Oh, sorry, sorry, sorry. We will also have to give the key in search part. Oh, we have to return this now, and this will return in bool format, whether it is true or false. So again, the working is simple. We have to search in the root left direction. If again in left root left, the searching will be done, and it will search for if the root is null at last, then it will be simply return false. And if we found the root, then we will return the true value. And same goes for right. If we find it and write subtree, then it will return true. And if it does not find until the last subtree node, then it will be simply return false. So compile it again. It should be work. Uh, we are making another mistake, that is we are providing the node part. It does not require declaration. Finally, compilation will be done. Now we have to submit this code. This will pass all test cases in first attempt. So this is the working of our binary search tree, how we will perform search operation in our binary search tree. So that's all for this video. Thank you for watching.